Okay, in this lecture we will look at how to use Wireshark to capture some packets running over a network, and how to use some of the filters, which the filtering capability in Wireshark is very, very good. There are hundreds and hundreds of filters that you can use to reduce the number of packets that you're viewing at one time. It becomes almost impossible to try to interpret everything that you're seeing on the screen, but by reducing the number of packets that you're viewing at any particular point in time, it becomes easier to follow along with what's doing. So obviously you will do is to install Wireshark, and I've already done that, but just sudo aptitude install Wireshark. And of course Wireshark is a packet analyzer that is open source, and therefore means it's pretty much available for any operating system. It runs well under Windows, the Mac, and Linux, of course. So once you install that, there's a couple of ways to capture packets. In an earlier lecture I showed you how to capture packets in TCP dump. Here we're just going to do this straight through Wireshark, and I've had trouble in the past on occasion, as have other people who posted on the internet, about capturing packets through Wireshark running on Linux. It seems to do it quite easily in Windows, and that's because some of the permissions are involved. But I just ran this again under Mint 10, and it worked well. So what we'll do is we'll just go ahead and demonstrate how to do that. Since you're going to be running the Berkeley Library Packet Capture utility, you will need to run this as sudo, and we can type Wireshark and then run that in the background, and it opens up very quickly. Let me turn down my music here. Notice that we have the caution message running as user root and group root. This could be dangerous. That is true. You can dismiss that. And over here on the left you see all the different sources of information in that you can capture, all the different interfaces. Here we want to capture from ETH0. Just a cautionary note, you should do this at your house. If for any reason, if you're on a hub network, obviously you would have the capability of seeing everybody's packets in here. That is strictly against federal and state law. If you're running a switch, you should only see your traffic. And this is obviously done for educational purposes, and the reason is that if you're in an organization and management has provided you the requirement and the responsibility and the rights of analyzing network traffic, then you need to be able to capture said network traffic if need be for reasons that are indicated by management. At the top you'll see that we have our traditional menu. Down here you have icons that correlate with a lot of the menu options up here, and if you ever need help you can show how to capture sample captures. But what we want to do is we want to capture our own. Notice that I've just downloaded, or I've just captured a small file here. I just called it file. It's good to name your packet captures appropriately, and I usually have the extension pcap, but notice that Wireshark knows that that's a packet capture file. So let's go ahead, and you can either go to capture and interfaces. And this is the long way to do it, but it shows you all the devices on which you can capture packets here, and then you can start over here. Would start the packet capture process. Let's go back here and do it the easy way, and double click on ETH0, and it's not doing anything. Why not? Because we haven't generated any packet information. So we'll just do this quite simply by going up to web browser and going to a couple of sites. Let this download. And then we can close this. If we go back over here, we'll see that it's still capturing in here. And if we want to stop our packet capture, notice that if we had this icon here with the red X, stop the running live capture. That's good. So we'll stop that. And now what we have is that we have our packet capture that has been read into Wireshark. Now, one of the real powerful capabilities of WireShark is using the filter menu, and there's a couple of ways to do it. If you're familiar with some of the filters, and as I said, there are hundreds of them. In fact, let's go to filter, and what this does is it shows you some of the default filters in here, and then you can add your own default filters if there's something you're doing over and over again and you don't want to have to wade through the menus. You can use this, but notice here there's quite a few filters showing IP only, a specific IP address, TCP only, and so on. And if you've typed in something previously, and you see that I've typed in several things before, you can go back and select one of these. If you go to expression, this is the filter expression, so this shows you all the different filter expressions that you can use. And notice that you have the top layer up here. If it's got a hierarchical menu of sub items, you can click on this right here, the little plus sign, which will take you to the sub items. And now if you want to scroll down, you can see how many different types of protocols and different filters that you can use. There's one for BitTorrent right here. And I just wanted to quickly get to something down here, but you can see if we click in here, and let's look for a specific IP. If I type I and then P, notice that it goes directly to Internet Protocol. Notice that it's searched right here. And then we can search by IP version, the header length, and if we scroll down, the source address. Now, that's only part of the information that is required. You also need to have a relational figure here where the IP source is present. A lot of the times for IP address, obviously you're going to use is equal to or not equal to, and then we can select the IP address over here, and of course we would have to know what IP address we were looking for. Got 30.129. We can see this right here. We click OK, and notice when I clicked OK that this field, the background changed from white to green, and that means that it's a valid expression. That means that IP.source is a valid filter. The equal signs is a valid relational operator, and this IP address is valid as well, meaning that this IP address shows up somewhere down in the packet capture. That brings back all the packet captures, all the packets rather. Let's go back here and select that. Let's change this to destination. Notice that it turned red. That means that IP dot, as soon as I took out the source, it was no longer a valid expression. If we type a D, S, T, notice it now shows in this drop-down menu. That means it's a valid filter. So let's pick another IP IP.src. Notice it turns red again, equals, and it will stay red until you give the full filter. Notice here we have a source address of .30.2, so let's try that. 192.168.30.2, and we can hit apply. And now we see that the source address is .30.2, and these are all the different packets that meet that criteria. It's clear to get all of our packets back. And now let's say we just wanted to see all of the packets that were over protocol TCP. If we type TCP, notice that it gives us two possible filters. If we just click TCP and click apply, that gives us all the packets that are running over TCP. Notice that it also includes higher order packets higher in the stack because there's some HTTP in here. Notice there's some resets in here. Usually the resets are going to be in red. And by the way, you can tailor these background colors to anything you'd like. It's not something I'm going to go over in here. Let's clear that. If you want to do the same thing with DNS, you can hit apply. There are all the DNS Notice that there's queries as well as responses. And let's go to HTTP and click apply. And notice now that the protocol, it's going to include the lower level on TCP because now we're talking about a higher protocol level. And if we want to follow these, now obviously these are just simple packets, but it's not the reassemble packet. Oh, by the way, let's quickly talk about this down here. I know I'm doing this a little bit out of order. I've already got a Wireshark lecture where I explain all this, but let's just go through this. So what this is showing is the encapsulation of the packet, starting at the lowest level of the TCP/IP model. You get the frame level. Here, notice that also it's got, if you open up the with a plus sign, it shows you all the different information that's contained at this level of the packet. Notice down here, protocols in the frame are Ethernet, IP, TCP, and HTTP, so that's kind of nice, although we knew that just by looking at this higher level right here. And then you have the media, the MAC address here of both the source and the destination, running in VMware. The IP addresses, source and destination. The flags, the time to live. Time to live should tell you that's a MAC right here. The TCP level, now we're talking about the ports. Obviously this is a client-side selected ports that's non-privileged, or rather not a well-known port, which means this is going to be selected randomly on the client side, and then the destination port obviously is HTTP, is web. It tells you the sequence number, the acknowledgement number, and the length of the packet. If we keep moving down, now we get to the highest level, which is HTTP, and this gives us more information about exactly what's in the packet, what is being requested. Now this is a GET. It tells us information about the host, the HTTP number, the user agent, running on Linux Mint 10. And if we go to the bottom here, this is the actual content of the packet. And so at the data level, that is the data packet information. So you can see this in both hex as well as the ASCII view right here. So again, this is just a single packet. If we would like to see what the reassembled TCP stream looks like, we can right-click on one of the packets, follow TCP stream, and that gives you the content in both the ASCII format as well as the hex code down here. And then of course you can use any of these radio buttons down here to view this in different formats, although I think it's usually best if we keep it in ASCII format. If we don't want this string to be included in the packet capture, we can temporarily disable that by clicking filter out string. And let's go down here and let's pick out a keyword here. Let's say Lenny 10, because what we're going to do is we're going to go back up. We're going to clear this. So we cleared the filter, so now we've got all our packets back. And we're going to search all these packets for a particular keyword, and which in this case is Lenny 10. And so let's HTTP contains Lenny 10. So what this is saying is at the HTTP protocol level, which we just saw just before this, the contains means is the text string, whatever comes after this, if that is contained in the HTTP packet. So let's see if it'll find that. And there we go. So now what we have is we have a filtered list of packets based upon our match right here. So essentially what the contains does, and I believe matches works as well. Let's see, matches. Yes, contains or matches along with a keyword allows you to search through the protocol, and obviously it will have to be an upper level protocol in here if we're talking about the actual data contained in the packet. Let's search for Mozilla. Here we go. So we have our new packets, follow TCP stream, and somewhere in here we should find the word Mozilla. And let's close this. And there wasn't a telnet connection that we ran previously. Let's just go ahead and type telnet contains keyword. And notice that this is a valid filter. Telnet is a filter, contains, and then keyword. If we hit the apply button, what this says is that this filter did not match any packets. If a obviously if a telnet packet, which would be at the application layer, did contain the word telnet or anything of that nature, then that would show you the packets contained therein. Okay, let's go up to statistics. And this gives you a good idea how many packets were captured, how long the packet capture lasted, the average number of packets a second, the average packet size, and so on. That may or may not be useful. Notice that there were 67 drop packets. Wow, that's quite a few for 2136 total packets. Very good display of the protocol hierarchy. Number of Ethernet packets, of those, 99% of the packets were IP. User datagram protocol, of those, about 6%, and so on. You can see kind of a good overview of the statistical nature of the packets that are going across your network. And sometimes this kind of information is used in an anomaly detection system. That's an intrusion detection system that does a statistical analysis of your packets crossing your network, going over your network for a particular period of time, which is usually days or weeks or months. And then it compares the traffic that's currently going over your network with what it normally sees. And of course, this is a very, very simple illustration of that. I mean, there's hardly anything going on here in this packet capture. But what the anomaly detection system does is that if it looks at anything that statistically is out of bounds, it can alert you as a possible anomaly on your network. So it's just a different type of intrusion detection system. And a lot of this other stuff I will let you do on your own, the I/O graphs. If you've got any telephony going on over your network, you can use any of these analytic tools. And so this provides just a real simple overview of Wireshark, and more importantly the filters, and how you can use the filters to try to identify the things that are going on in your network. It's still going to require some trial and error to look through your packets, but at least by using the filters you can reduce the total number of packets that are viewed at any one point in time and help you better able to identify what's going on.